So in the previous class you have copied on the question. Am I audible? Hello? Hello?
Yes, sir.
Okay. In the previous class you had copied on the question,
Sir.
copied the question, explain the process of generating digital image and explain the concept of sampling and quantization. Okay. So I already know that in order to create a digital image, what we require is the reflected light. Okay. The reflected light intensity will be captured by the sensors and it will be producing the digital image. Okay. So there are numerous sensors which are available in the market which can capture the intensity of the light and it converts it into analog waveform or analog voltages. Okay, but these analog voltages has to be converted into digital quantity. Okay, so that is done by two things. So the first one is the sampling. Okay, so you need to perform sampling, and the second one is the quantization. Okay, so quantization. So these are the two major steps which are required to convert an analog signal into a digital signal. Okay, basically the sensor will be performing the conversion of image light intensity. Okay, so what happens is whenever the reflected light of an object falls on the sensor, it captures the intensity of light and converts it into voltage waveform. The voltage waveform will be continuous in nature. We need to convert it to digital quantity, so it will be done by using sampling and quantization. Okay, let us look at this by making use of the image. Okay, so this is the object. Okay, so this is the scene or the object which you have seen earlier. So if you remember in the previous class, so this was the scene, okay, which was to be captured image system. Whenever the light falls on this scene or the object, the light gets reflected and it will be captured by the imaging system, and the object will be formed in the array sensor. So this is analog in nature. Okay, since this is the output of sensor, this is analog in nature or continuous in nature. We need to convert this into digital. So this will be done by using two methods. One is the sampling and the other is the quantization. Okay, so if we observe this image, so this is continuous in nature. So this is the continuous image. So what we'll be doing is we'll be drawing a line. Okay, we'll be drawing a line. We'll be calling this line as the scan line. Okay, so it starts from point A to point B. We are taking a scan line. Okay, then the intensity of that scan line is being plotted over here. So this is your point A. If you look over here at point A, there is white color. Okay, from here to here there is white color. So they are taken from here to here the maximum intensity value, that is 1. Okay, when you come over here it is very dark, so the intensity has fallen to the lowest value. Okay, again the intensity is gradually increasing, so it is increasing, still it is not brighter, but again when we reach here the intensity is decreasing, so it is decreasing at this position. Okay, at this position we are moving from 0 to 1. Okay, then from this location to this location, the value is high. So this is the plot of scan line intensity. Okay, so if you observe this is continuous in nature. Okay, this is continuous in nature, so we are saying that it is an analog signal. Okay, clear with this? Hello? Hello?
Yes, sir.
Okay, now what we need to convert this continuous time signal into discretized signal. So in order to do that, there are two processes, as I said earlier. One is the sampling and the other one is called as quantization. Okay, so what do you mean by sampling? Just give me the general answer. What do you mean by sampling? You studied in signals and DSP, right? What do you mean by sampling?
Construct the signal.
Constructing?
Taking the values at a particular interval of time.
Taking the values at particular interval of time. So it's nothing but discretizing or digitizing the coordinate axis. Okay, digitizing the coordinate axis is called as sampling. So if we consider here, there is a one dimensional signal, so this is your coordinate axis x. Okay, so if we digitize this, okay, or take the samples only at some interval of time, okay, only at some interval of time, it will be called as what? Sampling. It is nothing but coordinate axis. So here, if you look over here, you have taken the samples only at this locations. Okay, you have taken values at only at discrete interval of time. Whereas in case of analog, the sample is continuous. Okay, for every instance of time there is a particular value, whereas in case of a digitized or sampled signal, there will be a corresponding value only at some particular location. So this is called as what? Sampling. Okay, clear with this? Sampling means what? It is nothing but digitizing the coordinate values. Okay, clear with this? Hello, hello.
Yes, sir.
Yes, sir.
Okay, next thing is you need to quantize the value. Okay, so in order to quantize the value, it is similar to the sampling. Instead of digitizing the coordinates, we digitizing the amplitude values. Okay, here we are. So here, if we consider the intensity value is what? Continuous in nature. Instead of that, we'll be quantizing or digitizing at only at particular instance of time. Okay, so this is called as quantization. Digitizing the coordinate axis is called as sampling. Digitizing the intensity value or amplitude value is called as what? Quantization. So if we look over here, this is your continuous time signal. So this is being sampled and quantized. The result is this. So you're taking sample at this location. The value is what? The value is highest value, that is 1. Again, you're taking value over here. Okay, in between this, okay, in between this there is no value. Okay, okay, similarly this is 1 1. Okay, and at this location this is the value. Okay, so quantized the amplitude value. So this is regarding sampling and quantization. Okay, clear with this? Sampling and quantization. Hello, hello.
Yes, sir.
Yes, sir.
Okay, so first thing is you need to perform what? Sampling, perform quantization. So once you do that, you'll be getting the digital signal. So this was your continuous time signal or continuous time image. When you apply sampling and quantization, so this is the result. So this is called as what? Digital image. Okay, so result after sampling and quantization. Next, just copy down the question. What are the different parameters? What are the different parameters? What are the different parameters? What are the different parameters which will decide which will decide the number of which will decide the number of storage bits, will decide the number of storage bits of the image, storage bits of the image in discrete domain, number of storage bits in the discrete domain. So as I said earlier, okay, if we consider an image, it can be written as a function of two coordinates f of x and y. So x indicates rows, let us consider m is the number of rows and n is the number of columns. So if you are having a 2 cross 2, if you are having a 2 cross 2 image, so this is how it would look like. So there will be 2 rows and there will be 2 columns. So total there will be 4 elements. Okay, clear with this? An image is represented as a function of two coordinates x and y, where x indicates the number of rows and y indicates the number of columns. Okay, it can be m and n, or it can be a variable x and y. So if we take two rows and two columns, so there will be four elements within each element. Okay, each element is called as a pixel. So each element would be called as a pixel or picture element. We'll be calling this as pixel or picture element. Okay, so in order to indicate the color of this pixel, we'll be using k bits. Okay, we'll be using k bits. If there is only one bit, if there is only one bit, you can make use of only two colors, or either it would be black or it would be one. If you are using two bits, you will be having four colors. It will be 0 0 0 1 1 0 or 1 1. Okay, so in this image, okay, the total number of bits which is used for storage, if we consider it as a 1 bit image, so there will be two rows, right? There will be two rows and two columns into one, so it would be 4 bits of information. Okay, similarly, if we consider there are 2 bits instead of 1 bit, if there are 2 bits, we will be making use of 2 rows 2 columns into 2 bits, which would be how much? 8 bits of information. Okay, so there will be 8 bits of information. So the number of storage bits, it is nothing but number of rows into number of columns into number of bits, which is used to represent the intensity, okay, of the pixel. So there is a formula between levels and number of bits. So level equals 2 to the power of k. If they have given that image is having 256 levels of color, okay, so then it indicates what? 2 to the power of k. So what we will be doing, we will be taking the log of this. Log of 256 equals k into log of 2. So k will be equal to log 256 divided by log 2, so that would be k equals 8. Okay, so there will be 8 bits. Okay, if they are given, instead of giving the number of bits, okay, instead of giving the number of bits, if they are given the number of levels of color, we just need to find out the value of k by using the formula n is equal to 2 to the power of k. Okay, so this is regarding the parameters. Okay, the main parameters are what? Rows, number of columns, next number of picture elements, and then the total number of storage bits, and the levels. Okay, levels of colors which can be represented, and it depends upon the number of bits. Clear with this? Hello? Hello?
Yes, sir.
Hello, am I audible?
Yes, sir.
Okay, these are the parameters. Okay, rows,
Yes, sir.
columns, number of bits, and the levels. Okay, so when you represent an image, there are various ways to represent an image. It could be in terms of a surface, okay, or it could be displayed as an intensity. If you look over here, so this is your y-axis, okay, and this is your x-axis. This is your x-axis. Displayed the image in terms of intensity. If you look at the center D, it is white. Okay, outside and inside it is gray. Outermost is what? Black. Okay, so the value for black is how much? 0. The value for gray is somewhat 0.5, and the value for white is what? 1. So this is 1, so this is 0.5, and the value for this is 0. So we can view this image by displaying it in terms of visual intensity array. So this is one form of displaying the image. So this is what will be looking on the screens, okay, desktop or laptop screens. Okay, the other way of representing the image is by using the surface. Okay, here this value is what? The outermost is what? 0. So this is the 0. Next is what? 0.5, and this is what? This is 1. Okay, so here you are considering three axes, f of x comma y comma Z. Okay, so where Z indicates the level of intensity. So you can represent this using this notation, or you can represent using the intensity, or you can represent using the intensity values. Okay, so here they are given the numbers. Okay, so this is what we'll be using to perform processing of the image. Okay, this is just used to view the image. While performing processing by implementing different algorithms, we'll be using this representation of the image. Clear with this? Hello? 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 Clear
Yes,
with
sir.
this? Next,
Yes, sir.
if you answer this, this is the tabular representation of what I explained earlier. So here they are given only the value of n. Okay, n is, what do you mean by n? N means what? Hello, what do you mean by n? Hello, what do you mean by n? Hello, am I audible? Hello?
Yes, sir.
Okay, what do you mean by n? N indicates what?
Number of bits.
Number of columns. It would be n is nothing but n number of columns. Okay, m means number of rows. Okay, so here they are given only the number of columns. Okay, so you need to assume this as a square image. Okay, if this image is a square image, okay, the number of rows would be equal to number of columns. So given only the number of columns, so assume it as a square image. Okay, so 32 into 32, that would be how many bits? 1024 bits. Okay, there's only one, that is 1024 elements are there. In order to represent each element, they are using only one bit, so it is how much? 1024. If they are using 2 bits to represent every element, so it would be 1024 into 2, so that would be 2048. Okay, so into 2, so that gives you 2048. Okay, into 3. Okay, into 3 means that gives you this value. Okay, so as the number of row goes on increasing, okay, as the number of row or column goes on increasing, and as the number of bits which is required to represent the image increases, okay, the total amount of bits gets increased. Okay, as the number of rows and columns increases and the number of bits which is used to represent the element increases, okay, the number of bits which is used to represent image gets larger. Okay, so this is what we'll be coming to know with the table. Okay, next, so this is the problem which was asked in the exam. Okay, so for transmission we will be using packets. Okay, so the packets will be consisting of one start bit. Okay, it will be consisting of one start bit, a byte of information, and a stop bit. So then how many minutes would it take to transmit 1024 cross 1024 image with 256 gray levels? Okay, using a 56k bandwidth. So you already know that total number of bits. Okay, so total number of bits would be equal to, so it would be m cross n cross k. So here the total number of rows and columns would be 1024. So it is 1024 into 1024. So here the information is consisting of 8 bits. Okay, it is consisting of 8 bits. Along with 8 bit there is extra bit, that is So along with 8 bits there is one stop bit and there is one start bit. So totally the number of bits would be 10. Okay, so it would be 1024 into 1024 into 10. So this is the total number of bits. Okay, so this is the total number of bits. So what is the answer? So how many bits would be there? Calculate that. What is the answer? 1024 into 1024 into 10. Hello, what would be
So 10485760.
10485760 bits? Okay, so these many
5760.
number of bits, okay, these many number of bits are there in an image. Okay, so they have given that, so the baud rate 56K, so they can transmit only 56,000. Okay, so they can transmit 56K, so we need to divide this by, so we need to, so we need to divide this by 56. So the total number of bits is 10485660 bits. We need to divide this by 56K. The reason behind that is because we are using a bandwidth of 56K and that is baud rate of 56K. 180 187.25 180.25 seconds. Okay, so this is the answer. So if we need to convert this into minutes, we need to divide this by 60. Okay, so when you divide it by 60, so the answer would be 3.12 minutes. Okay, so the answer would be 3.12 minutes. So this is the information regarding the parameters of the image. One thing is the number of, so the first thing is number of rows, next is the number of columns, next is k is the number of bits. Okay, so here they are given the information as 8 bit. Along with 8 bit they are making use of one start bit and one stop bit, so taking that into consideration, 8 plus 1 plus 1. If they have not made use of this start bit and stop bit, it would have been only 8. Okay, so be careful over here. Okay, sometimes what they would do is, instead of giving it as 8 bits, they'll be giving it as what, 256 gray levels. You know that L is equal to 2 to the power of k. So they are given the levels. Okay, they are given the gray level as 256. 256 equals to the power of k, then take log on both sides, so the resultant k would be equal to 8. Okay, you just substitute the value of k over here. Okay, clear with this? Hello? Hello?
Yes, sir.
Okay, next is define. I just copied on this question. Define spatial and gray level, and define a spatial and gray level resolution. Briefly discuss the effect of resulting from a reduction in number of pixels and gray levels. Number of pixels and gray levels. So when you consider spatial resolution, okay, it is nothing but a measure of smallest discriminable detail. It is a measure of smallest discriminable detail in an image. Okay, so there will be two measurement units. So one is line pairs and the other will be called as a dot per pixel. Okay, so if we consider, let us consider line pairs. So here what we will be doing is, in case of line pairs, okay, so this is the image. Okay, whatever the blue color which you're looking at is an image. So in order to measure the spatial resolution, we'll be taking the lines, a pair of line. One is a black line, and then we'll be taking the white line, and we'll be keeping it on the image. Okay, so I've taken a So taken a black line and you have taken a white line. Okay, so these two lines form the pair of line. So these two lines form a pair and is used for measuring the spatial resolution. That is, consider the width of this black line is W and the width of this white line is also W. Okay, so the total width covered by one line is 2W. The total width covered by one line is 2W. Okay, so we'll be using some unit, okay, to measure the spatial resolution. Let us consider it as 1 inch. Okay, 1 inch is the spatial resolution which we are using. So let us consider the value of W is 0.1. So this is the width of a black line. So the width of white line would also be 0.1. So the total length 2W will be equal to 0.2. It will be equal to 0.2. So in 1 inch distance, in 1 inch distance, there will be 1 by 2W lines. In 1 inch distance, there will be 1 by 2W lines. So that is 1 by 0.2. What do you mean by 1 by 0.2 means? What is the value of 1 by 0.2? What is the value of 1 by 0.2? Hello? 5. Okay, so it indicates that there will be 5 pair of lines. There will be 5 pair of lines in this distance. In this space there will be 5 pair of lines. So this is the way of measuring the spatial resolution. So how many lines will be covering this 1 inch? Okay, similar to that, instead of line pairs we will be making use of dots per pixel. So this is the other way of measuring the spatial resolution. So this is the most commonly used way to measure the spatial resolution. So instead of taking lines, we will be considering the dots. So instead of considering the lines, we will be considering the dots. So one is the black dot, so instead of considering the lines, we will be considering the dots. One is white dot and a black dot, and we will be measuring for 1 inch. For 1 inch, how many dots are present? So that is called as dots per pixel. Okay, so these are the two ways of measuring the spatial resolution. Okay, next is intensity resolution. It refers to the smallest discriminable change in the intensity level. For example, if you are using only one bit, then you can measure only two intensity levels, that is 0 or 1. Similarly, if you are using 2 bits, you can measure 4 intensity levels, that is 0 0 0 1 1 0 1 1. Okay, similarly, if you are using 8 bits, you will be able to measure 256 levels of intensities. Okay, so it refers to the smallest discriminable change in the intensity level. Okay, so if you consider this is the reduction in spatial resolution. Are you able to view this image? Hello, hello, hello.
Right, sir.
Okay, so this is your original image. Okay, this is your original image. We are trying to reduce the spatial resolution. So in case of this, the resolution is 1250. If you can observe over here, the resolution is 1250 dots per inch. So what it is telling is there are 1250 dots per inch. For 1 inch there are 1250 dots per inch. If this is the case, okay, so this is what inch will be getting. Okay, if the same image is constructed only with 300 dots per inch, if it is constructed with if it is constructed with 300 dots per inch, okay, if it is constructed with 300 dots per inch, so this is the image. Again, if you are trying to reduce to 150, that is 150 dots per inch, so this is the image. And if you construct it with 72 dots per inch, so this is the image. So you just observe these two images. Okay, so if you observe here, it is looking somewhat blurred and you have lost most of the information. Okay, this is not clearer. Okay, so what does it indicate is, as you decrease the number of dots per pixel, so it will be having the blur. Okay, it will be having blurs. Okay, so if we consider this, so this is somewhat clearer when compared to this, but here you completely lost the information. So as you increase the number of dots per inch, the image would be more clearer, whereas if you decrease the number of dots per inch, so it becomes a blur image. So this is regarding the spatial resolution. Okay, so there are two ways to measure spatial resolution. One is using line pair and the other is using dots per inch. Okay, usually in magazines they will be using dots per inch for spatial resolution. Next, here we are trying to the intensity level. So here so taken a 452 cross 374 image, and the intensity level of this is 256. If it is 256 means there will be 8 bits. There will be 8 bits which is used to represent the intensity level. Okay, it will be 8 bits, whereas here it is 128 levels, and if we consider here there are 64 and here it is 32. So as the levels are decreasing, what is happening is the number of bits which is used to represent the image is up to 32. Okay, up to 32 the image may be looking like the original image, although most of the information is not lost. But when you try to decrease the intensity level further beyond 32, what happens is the information will be complete. So here the number of intensity level is how much? 2. So what does it indicate? It the value of k, or the number of bits which is used, is only 1. So with the help of 1 bit we'll not be able to reconstruct the original image. Okay, so this is regarding the intensity resolution. Okay, as the number of bits reduces, the quality of the image degraded. Again, in spatial domain, as the dots per inch reduces, the quality of the image will be degraded. Next is effect of image quality. Let us look at this in the next session. Okay, clear till here? Hello, hello,
Okay.
hello. Am I audible? Hello.
Yes, sir.
Okay, we'll be continuing it with the next topic in the next session.